In this example today, we're going to work on section 4.2 in preparation for the test. And in 4.2, we're doing substitution. So here's one I picked right from the practice in Math Lab. And here is your first equation in standard form. And interestingly, the second equation is in slope-intercept form, but they want you to use substitution. So again, the theory behind this is that if one of the equations is solved for a particular letter, like we see here, y equals this, then we can use this as a substitute for y in the other equation. So we're going to rewrite that. I'm going to have you rewrite it and work on this, and then I will do it as well. So let's pause. So hopefully you have something like this. 3x minus 6. Now the y value we have in terms of x, we're going to put in a parenthesis. Now we have an equation with only one letter, x. Here we had equations with two letters. But by solving for one of the letters, this one was already solved, we then have a value of y in terms of x that we substitute in the other equation. And now we multiply through. 3x, and again, be neat, negative 6x plus 30 equals 27. Now from chapter 2, combine like terms. Transpose the positive 30 to this side, or subtract 30. This becomes a negative 3. So we're subtracting 30 here, subtracting 30 here. We get a negative 3. Now we're going to divide both sides by the negative 3. We get x equals a positive 1. Now recently I was working with a student, and when they did the division, they failed to put a negative here. And of course, then we got the wrong answer. Now, if we know that x is 1 now, we have one member of our ordered pair. So how do we find out what y is? Well, we can go to either equation, but this one's already solved for y. So if we put y equals, we say x is 1, we put a 1 there, in place of the x, minus 5, we get y equals negative 4. Now again, on a test, I would put these values back in the original equations to see if in fact they are the solutions. And that way it would pick up if you had forgotten a sign somewhere. But neat and orderly is the way to go. And I'll raise that up just a little bit so we can see the bottom. In another example of section 4.2, they give us this system of equations, and again they're asking us to solve by substitution. So notice here we have an x, but it's not really by itself. And so what we're asked to do here is to solve for x. So we'll do that by just transposing the 9y to the other side, where it becomes a negative 9y plus 41. Now we have a value for x. So we're going to take this value and substitute it in the other equation where the x is. So this is what we want you to do and see what you come up with. All right, so first thing we should do is substitute 5 times, and in parentheses, 9y plus 41 plus 6y equals 10. And once again, we have an equation with only one variable. So we distribute to get rid of parentheses, a negative 45y. Now I used my calculator for this. This gave me a positive 205 plus 6y equals 10. I'm now going to combine like terms. I get a negative 39y. I'm going to subtract 205 from both sides, or just transpose it. This gives me a negative 195. Now I'm going to divide both sides by a negative 39, being careful of the signs. And we get y equals, this comes out even, as a 5. Now we know y is 5. We can then use this equation to substitute. X equals a negative 9 times 5 plus 41. Well, this is a negative 45. We can write it out here. Negative 45 plus 41 will give us then for x a negative 4. Now again, it's important when you write this in MATLAB that you write it in the correct order, that the x is first, comma, 5. Okay, this will be enough for lesson 4.2. Again, hopefully you've practiced, but as a little preparation for the test.